Continuing on with Chapter 1, Section 3, Day 2, Part B. Let's finish up this video. We're paying attention to these two special trig functions, the limits of them. So the limit as x approaches 0 of sine x over x equals 1, and then this other one. On problem A, limit as x approaches 0 of sine of 7x over 7x. Can you see what that limit might be? Well, if I thought of 7x, let's just say let 7x equal, say, w. I could replace then 7x with w. And let's just do that a little bit neater. Let's just say we're going to fix it up and we're just going to say, okay, 7x is going to become w for us. Then I end up with sine w over w. Well, that looks an awful lot like that, doesn't it? So as long as it's same over same, we're going to be just fine. So we're going to pull this off. Let's do that. So sine of 7x over sine of 7x is still going to be just 1. Because it looks like this, where I have the same thing over the same thing. Part B, this one does not look like the same over the same. I've got 5x here, but I have x there. Definitely not same over same. So what I need to do is make these the same. It would be lovely if we had a 5x down the bottom, wouldn't it? Well, here's the trick to doing that. Let me pull that back off. So let's make this into a 5x. But in order to do that, what I do to the bottom, I must do to the top. So we're going to go ahead and multiply both by 5 over 5, because that's like multiplying by 1. Next step, I will have the limit as x approaches 0 of sine of 5x over 5x. What did I do there? I joined together these two on the bottom. I let those multiply. Now, I can't forget about this, can I? So I still have a multiplier of 5 on top. So I'd have 5 times, I'm going to think of this as a group of things. And then, remember that scalar? This is like a multiplier in front of a function. I really could bring that out by that properties of limits. And simplify this all the way down to, now you're going to like this. It's going to look like 5 times the limit as x heads to 0 of sine of 5x over 5x. Same over same. When I think of those box ideas, I've got this sine of something over sine of the same something. And that will result in my outer 5 right here times the limit as x approaches 0 of sine of 5x over 5x. That'd be multiplied by 1. Final idea is it's a 5. Next up is the challenge problem. So it says in exercises 83 to 86, I pulled this from our textbook, the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. And you're probably thinking, wow, there's a lot of symbols going on here. Well, remember, a delta sign means change. So what they're really talking about is the amount of change of x as that amount of x value, or the change value, goes to 0. What would the limit of the function be? This kind of leads us up to stuff that we're going to do in the next chapter. So it does have a purpose to get you kind of prepared for that. Okay, let's just follow the directions. We want to take the limit as delta x goes to 0. When the change of x becomes hardly anything, goes to nothing. I'm going to have the function evaluated at x plus delta x. If this had just been like f of 3, what would we have done? We would have taken 3, substituted in every place we saw x. But it's not 3, it's x plus delta x. So we're just going to take and substitute it in its place, just like we would have done if it were a number to evaluate at. So I'd have 2 times x plus delta x plus 3, because that's the function. It says double the value and then add 3. Double the value, add 3. Minus Now take the function and just evaluate it at x. Well, that is what this is doing, isn't it? So that is exactly what I need to write. So I've got minus 2x plus 3, there's my numerator, all over delta x. We've got some simplifying to do. So the limit as delta x heads to 0, distribute the 2 through, we'd have 2x plus 2 times, and this delta x really is like a single variable. It represents a single number, plus 3 minus, and I really shouldn't have written it the way I did. We need parentheses up here, don't we? Because, no we don't, so sorry. Skip that idea, because it's just 2x and then plus 3. Okay, but where I need parentheses is right here then, because it's minus the whole function, and the whole function's this. All right, so we've got minus 2x minus 3. Okay, that'll make that right. On the bottom we have delta x. Adding things up, I notice that 2x and a negative 2x goes to 0, a 3 and a minus 3, 0 out. So I am left with the limit as delta x goes to 0 of 2 times delta x over delta x. Delta x over delta x would cancel and make 1. So I'm left with the limit as delta x goes to 0 of 2. The limit of a constant is the constant. 2 is our value. And then we'll work on homework tomorrow. The day 2 side is what we have yet to do.